So let's talk about Pearson's product moments correlation coefficients. We've probably talked about this before, but this is looking at the linear correlation, like straight line. It only cares whether, like your scatter plot, whether your data points form a straight line. It doesn't tell us how steep the line is or how shallow it is. It only tells us whether the data points line up. Do they line up in a straight line? So you can see over here on the left, perfect positive correlation is the value of 1. This R value is always going to take on a value between -1 and 1. And if these line up super straight and they're going uphill at all, that would be R equals 1. Whereas down here they're lining up in a perfectly straight line and they're going downhill, that's R equals -1. Again, this value doesn't tell us, it doesn't have anything to do with whether that line is very steep or not. It only is about whether those data points line up super straight and whether they go uphill even slightly or whether they go downhill. So as we get lower in our R values or closer to 0, you'll notice that they're sort of poofy. Like they don't make a perfectly straight line. They're sort of grouped together. It's a nice little cloud going in one direction, but it's not a perfectly straight line. So again, I cannot emphasize this enough. This is only for, does it form a perfectly straight line? So here it's very similar to above. We're getting different values because we sort of have these clouds of dots. But in this middle line, all 3 of these that are going uphill even a little bit, because it's a perfectly straight line, they all have an R value of 1. And here, even though they're downhill at different steepness, they all form perfectly straight lines. So those are all going to have an R, like a Pearson's product moment correlation coefficient of -1. And in this bottom row, sure, I mean, it looks like these variables are related. They're clearly making a really nice shape, but like it's not a straight line. Unless the data forms a pretty much a straight line, you should not be using the Pearson's product moment correlation coefficient. You would need to use some other statistic to describe your data. When you interpret this on IB, it will say, describe the correlation in words or interpret the correlation. You can pretty much do this little formula, which is there is a strength, strong, moderate, weak. And then next you need to say the direction. Is it positive or negative? Is it going uphill or downhill? Followed by linear correlation between name your variable and name your other variable. It's really just fill in the blank. You choose a strength, you choose a direction, you always say linear correlation, and then you just need to say between whatever 2 things are being measured. So here we have an example. Lucy sells hot chocolate drinks at her snack bar and has noticed that she sells more hot chocolate on cooler days. On 6 different days, she records the maximum daily temperature, T, measured in degrees centigrade, and the number of hot chocolates sold, H. The results are shown in the following table. The relationship between H and T can be modeled by the regression line with equation H equals AT plus B. So we can already tell by the way they've done this equation that this H is like my y-axis because that's the one that's alone. So this is my y and this is my x. This is 2 variable statistics. I'm looking for the relationship between the temperature and the numbers of hot chocolates that are sold. So it says find the value of A and B. This is actually a linear regression, not a correlation, but on the TI84, they're on the same page. So let's go ahead and do it all together. So the first thing I need to do is I need to add my data into the calculator. And I do that, I need to create a new list. And I do that under the stat button. So I press stat, and to add new data, I press edit. So I go into edit and I press enter. Right now they're blank because I erased everything. If yours are not blank, you can erase them all, or you can just keep going down the line to the right and adding new lists. It's really your choice. If you want to erase all of your lists, go back to like the main calculator, go to, sorry, this is the wrong thing. Inside stat, you would go to clear list. So you go down here and it just writes down this command, clear list. When you press enter, it's not working here because I don't have any lists. But if you did have any lists, it would then erase them and it would say done. So let's make a new list. I want to go to stats, edit, list one. Typically you'll do the X first, or like that top row. And we are going to turn that top row into this column. So I have 14, 8, 4, 18, 13, 11. There are all 6 data points for my X values. Now I need to do the second list. I need to put in the Y values. So I have 79, 143, 191, 58, 84, and 105. There should be like an equal number of observations for both X and Y. I mean, obviously from the table that we were given, like in the example, but in general, if we're doing this type of regression analysis or we're trying to find a correlation, we need the same quantity of observations for both variables. So first we created the lists. You might have to turn on whether it's going to show you your R variables inside this list or not, but let's go ahead and try it and let's just see what happens. So I have my lists already and now I want to do some calculations with them. So I'm going to go back to the main calculator. I'll go back to stats because it is statistics, but now I want to do a calculation. These are 2 variable statistics. However, on the TI84, it doesn't have a submenu. So although I'm doing some 2 variable statistics, I would like to currently calculate the linear regression. You can see there's a linear regression AX plus B, and down there, there's A plus BX. There's really no difference. Just notice that in this 4th line, the A is touching the X and the B is alone. And down here, it's the B touching the X and the A is alone. So you're going to get like the same numbers, just in the opposite order. I typically just stick with 4 because it's most like the Y equals MX plus B equation that I'm used to. So I press this, it automatically chooses list 1 as X and list 2 as Y. And in my case, that is how I entered them. I entered all my X values into that first column and all of my Y values into the second column. We don't have a frequency list. This was not a frequency table. Like that's literally, we typed out every single observation, which was only 6. It's not a lot. Store the regression equation. I do want to store it because I want to be able to use it in the future. So here we need to put one of our Y's, like Y1, Y2. So I will do that. And I want to do that by like choosing a variable. So I click this vars button. I click over because it's a Y variable that I'm choosing. And it is a function. So I press enter, and now here's like a billion Y's to choose from. I'm just going to pick the top one. So I press enter. They're all ready, so I press down. Oops. Just taking all these screenshots here, and then enter. It only gave me A and B. So because I reset my calculator, it turned off the ability to see the correlation, which means I need to turn it on. How do I turn it on? Let's go find out. So I need to turn on the diagnostics, and I'll do that with the catalog. But first I have to find the catalog. It's always a little tricky, I lose it. It's down here, this blue thing on top of the 0. So if yours is already showing the R value, your diagnostics already turned on and you're good to go. However, I need to turn mine on. So I'll go to second catalog and then scroll way down to diagnostics. I think you could probably start typing, but I'm not so good at this calculator and I don't want to push my luck. Here we go, diagnostic on. So I get to there and now I want to press enter. Now I'm in the calculator version and it's just the command. I need to run the command by pressing enter. Done. Okay, so back to where I was before. Let's do this linear regression, but I wanted to show me all of the information. So I go to stats. I need to do a calculation, and this is a linear regression. It's exactly the same thing as before because I just wanted to give me more information. So again, I go to vars, I choose a Y variable, and I'm just going to pick Y1. I already have something in Y1. It's just going to write right on top of it. It's not a problem. There we go. So now it's showing me all of the information I needed. It's giving me the gradients or the slope of my equation, which is negative 9.85. It's showing me the y-intercept, which is 222. And it's showing me my R value. And because this was with the actual data values that I plugged in, this R value is my Pearson's product moment correlation coefficient, which is negative 0.981. So if I were to interpret that R value, it would be a very strong negative linear correlation. So let's go ahead and write this down. It says the value of A and B. A, if you look here on the way that they've written it, is the one that's touching my t or my x variable. So it is going to be this negative 9.85. When I write my answers for IB, I will always round to 3 significant figures. However, when I use this equation later, I will not use the rounded form. So I need to make sure that I keep track of both of them. I think it was negative 9.85, but if we're being honest, I forgot a little bit. 9.85, yes. And B is 221.59, blah, blah. But I'm doing 3 sig figs. So I keep the 2, and the last one rounds to a 2. So this is plus 222. So A is negative 9.85 and B is 222. Now it says to write down the correlation coefficient. Well, that was in the same part of the calculator. So I just need to come here and look at this R value. Again, rounding to 3 significant figures. So it's negative 0.981. My minus sign got a little bit lost. And I like to always write the R just to have it there. It's not that important. So now we're on the last part, and it's using the regression equation. That's why I saved it to that Y1 value. I want to be able to use it to find more stuff. So using the regression equation, estimate the number of hot chocolates that Lucy will sell on a day when the max temperature is 12. So here, T equals 12. I want to plug in T equals 12 into this equation from above, but only sort of. I'm going to write down negative 9.85 times 12 plus 222, but that would be rounded, and I don't want to have a rounding error. So I will actually calculate it on the calculator. And I'll do that from a graph. So let's go over to a graph. So let's turn on the plot, like that it's going to plot little points on it instead of only the graph. So I go to second stat plots, and I need to turn on at least one of them. So I turn it on. The type, yeah, I just want this scatter plots. X is list 1, Y is list 2. You can choose whatever marker. I think the little empty squares are fine. And the color, you can choose whatever color. Blue is also fine. So that's good. So now I'm going to go back to my graph. Maybe my zoom is not fitting. And I could zoom in or out, but this graph is based off of the data that I put in. So I'm going to go ahead and zoom to this zoom stat. It's going to zoom to those list data that I put in. So here I have my 6 points and also my straight line. But I want to figure out what is the H, or what's the Y value if the X value is 12. And if I know the X value, I will always find it by using trace. So I go to trace, but right now it's going to trace the points. I'm not interested in moving across these points. I want to move on the line. So I press either up or down. It doesn't matter. And I can see up here now it's going to be tracing along my line. And I want to go to 12. So I type 12 and I press enter. It jumps to 12 on my line and I have 103.43, blah, blah, blah. But if I round that to 3 significant figures, it's going to be just 103. So my answer here is 103 hot chocolates. That is this whole question, and that's pretty much everything you would be asked in terms of linear regression and Pearson's correlation coefficients. And the reason they're going together in this question is because linear is straight line, and Pearson's correlation is for finding a relationship that makes a straight line. So that is how those two go together.